All right, this is going to be AP Calculus Lesson 5-4. We're talking about unique and exponential antiderivatives today. So let's talk about the unique power rule. Why do we even need a new rule for our unique power rule? Let's take a look at this example. So in this example, as we did on Friday, this is going to be turned into 12 times, and I need to bring this 3x plus 1 into the numerator by using negative powers. So it's going to be 3x plus 1 to the power of negative 1 dx. All right, so I'm going to use u substitution, not Taxman, and let's analyze what's happening here. So if I say u, I need to find u, I need to find du dx, and I need to use that to find dx. All right, so u, that's the inner, that's 3x plus 1. 3x plus 1. Du dx, that's going to be a derivative of this, that's going to be 3. And then dx, solving, is going to give this, what is that going to be? Dx is equal to du divided by 3. Du divided by 3. All right, subbing in here, we get, our new equation is the integral of 12 times, oh, it's not going to be 3x plus 1 now, it's going to be u to the power of negative 1, and then dx now becomes du over 3, du divided by 3, and that's going to simplify into, I'll do it on this line, into 4u to the negative 1 du, so the integral of that. Perfect. So now we're going to take the antiderivative. When I take the antiderivative, this will give us, u is going to go up a power, so it's going to be 4u to the power of 0, and then I need to divide down, and oh dear God, we have failed here. I guess plus c, so I can, it's still mathematically incorrect. I can't divide by 0. So what the heck is going on here? Let's take a look at our new rule. So we'll say our new rule looks like this, and it's whenever you have the integral of some number times an inner u to the negative 1, we'll leave our dx there too, that is always going to turn into that same first value, the same first number, so it's still here, and this is going to be multiplied by the natural log of that inner function. And don't forget c. So this guy should have turned into the natural log. All right, so that's our new rule. Go ahead and box it, start. It's one of the few rules that we have to learn today. Oh, let's try that again. Star this, box that. That is important. All right. And I guess I should have talked about where we are in our unit. We're on 5-4. We're right here. And then we're going to do our last antiderivatives lesson right after this on the weekend. All right, so moving on, we are going to make some copies of those. We're going to talk about some examples. Ejemplos. All right, let's do our first example. Let's do the integral of 6 over 2x minus 1. And don't forget our dx. All of that is multiplied by dx. All right, so what does this turn into? Actually, I should switch colors here, let you know that I'm working on this. This turns into the integral of 6 times 2x minus 1 to the power of negative 1 dx. All right, and now I need to do my u substitution again, so I still need to find my u. I'm going to say u is equal to 2x minus 1 du dx is equal to 2, and that means our dx is going to equal du divided by 2. All right, so subbing in, and I have our new integral, which is going to be 6 times 2x, oh, it's not 2x anymore, it's u now, u to the negative 1, all of that times du divided by 2. Perfect, and now I use my rule, so I have a u to the negative 1, and I have a number in front of it too, so this is a great example. I have a 6. Actually, it's not a 6 because this will actually simplify. I'll write this over here on the right really quick. This is going to simplify That was a horrible arrow. Let's try this again. So we'll simplify to 3u to the negative 1 du. So I know that when I take the integral, I'm using my rule, and this is going to be 3 natural log of u plus c, and that is going to turn into 3 natural log, and what is it? U was 2x minus 1, 2x minus 1 plus c. Perfect. There is our final answer. Let's try another one. Let's try number 2. So let's evaluate the integral 4 over the quantity of, let's say, 1 minus t. And we'll say all of that is with respect to t. If I had dx here and t here, that means we're multivariable calculus. Make sure your t's match each other. All right, so rewrite this. Let's see if we can skip some steps here too. So if I rewrite this, this is going to turn into the integral of 4 times the quantity of 1 minus t, all of that to the negative 1 dt. And I know what my substitution is going to be. This is going to be, when I take my du dx, I'm going to get negative 1, so it's going to be du over negative 1, and that is going to make all of this being multiplied by our negative 1. So if I should have changed this to a different color too. Oh well, it's too late. This is going to turn into, wait, I do have a question. Can this all just change to blue? That would be pretty, oh my god, that is pretty cool. Okay. This can all be turned into the integral of negative 4u to the negative 1 du. So the only thing that I did there is I skipped these steps, 1, 2, 3 steps, where I solve for du over negative 1, and then I have du over negative 1, which is the same thing as negative 4 of all of that, and I still have my u substitution. That is now going to turn into negative 4, I'm actually taking the antiderivative now, negative 4 natural log of u, and I'm not going to write u here. I know what u is. U was 1 minus t. 1 minus t, all of this to the, oh yeah, it's just natural log of 1 minus c. That's all I have to do, and don't forget to add c. So you can skip steps like that. All right. Let's go ahead and just talk about the 2 most common things that you'll see on the AP exam. And I think I can squish them in right here, as each of them are going to take 1 line. So these 2 things, we'll say common on AP test. And that is these 2 problems. 1, the integral of 1 over x dx. You should be able to know that that will immediately go to x to the negative 1, which is similar to the form that we talked about over here, something to the negative 1, and I'm taking the integral of that. So you automatically say that is the natural log of x. You should just memorize this thing. The integral of 1 over x dx is the natural log of x plus c. The other thing that you need to memorize is anything that looks different, if it's a t or a b or a q. So 1 over, let's just do a t dt. That's going to turn into natural log of t plus c. These 2 things, you just need to memorize them. So we'll make a note here, memorize these things. Memorize. This. You have to be able to go backwards and forwards. Remember when we took natural log house? We did 1 over that value of x. So you technically now have the ability to go backwards and forwards between these 2. It's not just one direction, it's the other direction as well. So both of these you need to go back and forth. Remember, log house derivative is 1 over whatever the inner is, and then d inner. All right, so moving on. Let's talk about some exponential and antiderivatives. So here we go here. We'll say exponential. Exponential antiderivatives. Antiderivatives. All right, so what's our example here? So let's say we have an integral of 2e to the power of 4x dx. All right, so what house are we in? We're not in power house. It looks like it's in a power. We're in this house, E house. E house is similar to tree house. You go up in a tree house, so this is the inner. So that means if I'm looking for my u, and I'm also going to look for du dx from there to find dx, u is going to be whatever is in the top of E house, or in the top of tree house if you prefer to say it that way. So the u is 4x. Du dx, take the derivative of u, and that's going to be 4. And then solving for dx, and I say that that's going to be du divided by 4. All right, so using all this information, we'll make this a little bit clearer. I'm applying this information now, so this is going to turn into the integral of 2e, and then I was going to write 4x, but it's actually to the power of u, and that's going to be a dx here, but remember dx is now du over 4, so du divided by 4. And simplifying this a little bit more, this turns into e to the power of u, and I guess I can just leave this as 1/2. I was going to say all of this over 2. It doesn't matter, it's the same thing. Du, we make sure we have only one variable, we're in single variable calculus. All right, so now what do? We're going to anti-differentiate, and do we remember the rules for going forward? And maybe I should do the going forward rules out here on the left. So if I have d dx, if I'm taking the derivative of ae to the power of u, because this is the inner, this is going to equal what? See if you can remember. E house. Yeah, that's the same thing. So it's ae to the power of u, and then we multiply that by du dx. Multiply by inner. So this is daughter times dinner. So to go backwards, once we just have one variable, then we don't have to worry about the inner anymore because we've dealt with that by our u substitution. So if I'm going backwards for E house, it's the same. Just like going forward is the same. So that is going to make this thing. Oh, whoops, did I not write my, whoops. I should have wrote the integral there. So that means when I take my antiderivative now, this is going to be 1/2 e to the u plus c. And remember, we were given an x, so we end with an x. So this is going to be 1/2 e to the power of, and u again was 4x right here. So e to the power of 4x plus c. So we have to learn each of our houses backwards. We've done power house, we've done E house, we've done natural log house, kind of, with this one. All right, so what else do we need to learn? So I'm on my second page now. I think that's it. Yeah, let's just talk about some examples. So examples. The first example, let's take the integral of -1/3 e to the power of 6x. And don't forget our dx. Okay, what is that going to turn into? So hopefully I'm going to do my u's. Instead of doing it under here, I'm going to do them all here. U equals du dx equals, and dx equals, and I can just go through a straight line. So u will be, remember, it's in the upper tree house. It's up in the top of the tree house, 6x. Du dx is therefore 6. Dx is du divided by 6. And that will change our equation to become, I still have my -1/3 e, instead of to the power of 6x, it's now going to be to the power of u. And I have a dx, but dx is du over 6, so I'll sub in du over 6. And I'm going to rewrite that to make it even more simple. I'm trying to give enough room to do number 2 down here. And number 2 is going to be our final problem. Actually, I'm looking at the notes. Number 2 is a really, really long problem. Let's go ahead and just take up this whole room, and then we'll do number 2 on the next slide. So this is going to be negative 1 over 18 e to the u du. Oh, integral of that. Oh my god, I'm forgetting my dx's too, aren't I? Oops. Dx. Oh, not dx. We've gone to multivariable calculus. Du. Wait, I didn't forget du. I'm just not knowing what I'm talking about. So this is going to be taking the antiderivative now. So e to the u is still e to the u. So this is going to be negative 1 over 18 e to the u. And I'm not going to write u, I'm just going to do it all at once. U is 6x, I'll say that that's 6x, and don't forget our plus c. Alright, second and final example, here we go. We have the integral from, not from anywhere, it's just going to be the integral of 2t, all of this divided by e to the power of 4t squared. 4t squared. Alright, and don't forget our dt. So let's go ahead and make this a little bit easier on ourselves. I don't like fractions in calculus. They make my life harder, they make your life harder. So let's get rid of it by using negative exponents, and that's going to be the integral of 2t times e to the power of negative 4t squared. Don't forget our dt. Alright, so from here, I now need to, and if you don't understand that rule, it's technically saying, I can write this in the side margins too, I should have done this, but it's technically e to the 4t squared, all of that to the negative 1, but when you do an exponent to the exponent, this exponent is multiplied through to give us our negative 1. So this negative 1 gets multiplied down here, just in case we need some review on rules of exponents. So from here, we need to figure out our u, we need to figure out our du, oh, be careful here, it's not dx, it's dt, it's whatever it's given right here, dt, and that's equal to, and did I even do that in the other slides? dt, I didn't even do u substitution here, I should have mentioned that, but I'm mentioning it now. So whenever you do du with respect to something, it's with respect to whatever the original problem was, du dt, and that'll finally solve for dt, because that denominator is what we're solving for to replace this dt. That's why it makes sense. Okay, what is our u? We have a bunch of stuff to choose from. So generally speaking, it's going to be the most complicated thing. So you can kind of think of this thing, this 2t term, as the tax man, or the a when we're talking about our general formula for, where was our general formula? Oh, it was up here. Our a out in front. So that means that we're going to be dealing with this guy. Usually the most complex term is going to be where you're finding u, and it's e house, tree house, so it's going to be up here, and that's going to be negative 4t squared. So du dt is a negative 4, oh, no it's not, it's a negative 8t, I multiply the 2 down and subtract 1, and solving for dt gives us du divided by negative 8t. Alright, so from here, that is going to change our equation. So this equation now becomes the integral, and I'm going to write my negative 8t underneath my 2t. I could put it out here, but I think that's easier to see what's going on. Maybe not. I know that eventually it's going to cancel out with this term, but I'll just rewrite it like I did before. So it's going to be e to the power of u, and when I do that, my dt is going to be du over negative 8t, so du all divided by a negative 8t. You'll see that the t's should cancel out, because otherwise we'll have multivariable calculus, we'll have t and a u. And what is that going to become? Simplifying this a little bit, we have a 2 over negative 8, that's negative 1/4. And the t's cancel out, and I'm just left with e to the power of u du. Much, much easier than this thing that we were given. Look how far we've come. Alright, so let's go ahead and take the, I have plenty of room, I'm just going to go down the next line. So from here, I'm going to take the antiderivative, and antiderivative of e house is e house, just like going forward. So this is going to be negative 1/4 e to the power of u plus c, and I'm not going to write u, I'm going to write negative 4t squared. Negative 4t squared, and I was going to write plus c. And there it is. A little bit harder. All right, go ahead and write your summaries, and remember that we're doing not only this lesson, not only 5-4, but 5-5 over Thanksgiving break. All right, thank you.